Objexlab, we can shape the future together.
We chose our project, the assignments they gave us, the solutions that we have come up with so far, and our ideas. Then the decisions based on morphological map that we had, and of course, in the end, what will be the next step for us. A little bit about the company. I don't know if you have heard about Eindhoven. It is a very big company. It's a global leader for power distribution. But it's mostly about the electrical devices, but it also has branch in hydraulic and pneumatic systems. It is worldwide known for its power management solutions, and it also produces systems and services in power control, quality, and distribution. It is placed in Hengelo. Eindhoven is experienced with more than 100 years of experience. It has approximately 102,000 employees in the world, and it sells its products among 175 countries. On the picture you can see the Eindhoven's electrical products for medium voltage chain, and our project is focused in the medium voltage ring, specifically in switchgear called Xeria. And Uri will tell us more about Xeria and our project within Xeria.
Yeah. So, Eindhoven use Xeria as a switchgear, and they use that product for distribute properly the power distribution, electrical distribution. So they use Xeria almost everywhere. You can find Xeria in residential houses, factories, big offices, big big factories. So almost everywhere, and in substations, distribution substations. So it is used for if they connect or disconnect the switchgear, they use it for give more power supply or less power supply. Just for that, just keep that in mind. So when Xeria is this box, the whole box is called Xeria, is the product itself, so they produce everything in it. And it's used, as we said, for medium voltage. And our project, the thing that we will design is, as you can see, these holes. So we will redesign the hole itself, so just the ring, the black part here. So they have, in Xeria they have three types of holes. The one is used for safety reasons, to release the pressure. The other one is for maintenance. And the third one is just the window, to look through it. So they have a lot of electrical stuff in Xeria. So they only need to take a look through the window to see if it's working as they want or not. So in 2 seconds they can see if it's working. So this is where our project hopes in. The main difference between the competitors and Eindhoven and this product is that they don't use SF6 gas because it's not environmental friendly. So they need more electronic stuff. They need more protection to circuit, so they need more components. So they need this window to check if everything is correct. So our project, of course, is to create an improved design for 3D printing in terms of cost and assembly time. Syria department is not, they used screws to fix our black part, our rig. You will see a picture in detail further on. They used screws to fix this part into the door of the box, but they were unsatisfied and they wanted to change that. So they wanted to innovate, and now they are using bayonets. But they are still not satisfied with it, with the result, with the outcomes. So our project is to give them new ideas to innovate, and this is perfect for 3D printing because you are thinking first of all about the function, and you don't care about the process of producing it. So we are free to design. This is like one company requirements. First of all, manufacturability. This means what I already said, that they still have problems with producing the part, our ring, this black ring. They still have problems with it, so they want to make the process easier. Assembly. They are using bayonets, so they are not happy with it. So we can change that. During fault situation, what does this mean? If you want to connect or disconnect the switchgear is not that easy as push a button. The temperature is increasing a lot. So if everything goes wrong, if something fails, you can have an explosion and you can have a big accident in it. So our device, the more extreme conditions that can hold, the better. And this is also good for mechanical stresses, because you can imagine that Syria is used high in the mountains with extreme conditions, environmental conditions, high temperatures, low temperatures. So the more extreme conditions that our device can hold and can work properly, the better. And more product specifications. They want this product, it must work for 30 years or more. They don't want problems with it because they have another more important problems. The temperature and yeah. So and you can you can see here the details of the bayonets here. This is the product that they are using right now. So we have the bayonets and all the details. And one thing that I forgot is that this last property is not the less important. I think it's the most important because it must be airtight if we want to Syria keeps working properly. Because as you know, the switchgear must be in stable conditions. It cannot be affected from the outside. So it must be airtight for sure. This is the most important property. And after that, we will explain our solutions, our possible designs.
Thank you. Good morning. So, after extensive research, literature research and discussions, we came to the conclusion that we could apply the following mechanisms. The first is cap mechanism. It is similar to the mechanism which is used to lock the caps of plastic boxes and the pins. One half of the part that is female has a double ridge around the perimeter of it, and the other half of the part has single ridge. So when we push the female part to the male part, the single ridge slots into the double ridge. The second is bayonet mechanism. In this mechanism, we have two parts. The one is the male part, which has teeth-like structures, and the other is the female part, which has slots in it. So when we push the male part and rotate it, it will lock. It gets locked. So the third is screw mechanism. This idea uses the mechanism of threading, like a nut with the external threads. You can see here the nut with external threads. The part can be screwed into the switch gearbox easily and can be unscrewed when the maintenance is required. So next is designs, possible designs.
So we came up with the designs, we came up around 12, 13 designs, and then we jotted down to 3 and then to 1. So we came up with the mechanisms first because we wanted to let you know that what are the mechanisms that we are using. Right now we have 3 designs and we have 9 mechanisms which we are working on. And then we come down to 1. So design 1, 2-part 3 design. That's we choose the same path. That would be the least important design in our consideration, because then we choose the company path and the way they are designing it. But we improve. The company right now is using bayonets, but then we can reduce their cost by using the screw mechanism or the cap mechanism, which we already explained before. Then because of that can improve. Basically, the company wants the visualization, and with this product, with keeping the company's product, we can actually put the polycarbonate in it as well, and put the cap mechanism or the screw mechanism instead of bayonets. Bayonets are expensive than cap and screw. So the second design, which is really innovative and which we actually brainstormed a lot about it, was the hamburger. Why we kept the hamburger is we have 3 parts with the product. One would be the metal part, the next would be polycarbonate part, and the next would be the metal part again. So this is a hamburger in our product. So why we chose this? Because firstly, we need the polycarbonate part to visualize. That's our main project, and the metal part just to give it strength and just to make it more reliable and more efficient. So as we can see, these are the pros of the hamburger. It would be obviously be efficient because 2 materials are used, and the polycarbonate is a very strong material as well as metal. It would be reliable for sure. Solve the purpose because the company needs to visualize it, and we are solving their purpose. Gives it strength, gives it a lot of strength. And 2 material properties, that is the polycarbonate and the metal. The metal, then the polycarbonate, then the metal. So this is like this. Okay, but more material used because of the polycarbonate, and the cost. Cost comes into play. So we actually were thinking of developing this idea, but then we crossed it because of the cost, and it might not be 3D printable because it has 3 products. So then we came up to 1-piece polycarbonate. This we did a lot of research and came down to these 3 points. As Uri told you that our product works on very high temperatures and very low temperatures as well. So with polycarbonate, we can actually solve the problem that comes as temperatures as low as -50 without pressure and as low as -40 with applied pressure. -40 is a lot of low temperature, and with the applied pressure, we can use the polycarbonate. If we just use this 1 piece, and it would be 3D printable, and it can work with -40 as well. The second, that the polycarbonate does not present any fire hazards. So in the project, there are many problems that companies facing. With polycarbonate, we can actually resolve the problems, and it won't produce any fire hazard, and it has self-extinguishing properties. The third, polycarbonate is the most heat resistant transparent plastic, I would like to show that the transparent is the most important thing in our project, and able to bear explosions up to 120 degrees Celsius. 120 degrees Celsius is a lot of temperature. And so with polycarbonate, we can use the cap mechanism, or the screw mechanism, or the bayonet mechanism. So this polycarbonate has several 3 designs, but then we brainstormed a lot, and then we came down to one mechanism. That would be the screw we would be using. Now, why the screw? Why we chose that? Everything will be told by Gwen now for the morphological map, and and analysis we did on this project. So.
Okay, for the morphological map, so as a record, I want to zoom one.
Yeah.
One click. Yeah, one click it doesn't work. No, never mind. So I will end with that, but first I will explain how I did it. So I used Kessel ring method, and that method. Sorry, I can't go. No, we can't see. I can go. I can zoom. So I will explain. So Kessel ring method will just.
You have 5
take.
more minutes.
Sorry.
Yeah, 5 more minutes.
Four,
Alright.
actually,
Oh,
but-
4 minutes.
Okay.
And,
Okay.
also the question you find is up. So because you're already talking 16 minutes.
Okay.
So just speaking.
Okay. It takes all our requirements and goals and just wait each other. And after that, you have a waiting factor. Can you go there? With that waiting factor, you take every requirement and goals, and you multiply by the number you give to each design. Each design for each goal, so you give a number from 1 to 10, and you multiply. And at the end, for each design, you add, and you have a number. That number you can choose. So higher is a number that will be the design you will choose at the end. At least you will focus on it. So for us, it's design 6. So design 6. So on the morphological map, design 6 will represent 2 battery design. That's the main design. And we, for the mechanism 1, I mean the mechanism between the box and the product, we keep bayonet. And the mechanism between the 2 parts of the product will be a screw. So it changed because at the beginning it was the mechanism cap. So it changed. And I think that I put more design 2 and 3, but it's with a number, it's design 3 and design 11. But I will just present the first one.
So, no. So, this was it. You can see we did the first 2 phases of our project, which is brainstorming, getting the assignment and brainstorming the solutions. And now we're focusing, in the next quarter, we're focusing on the details about the design we chose, the 3D printing, what we learned already for 3D printing, how we will use it. And in the end, we draw the card, make the STL file, and print it, and then test it, validate it, and draw our conclusions. And that's it. Thank you very much.
So yeah.
Have you thought about thermal expansion? We want to use it between minus 30 and plus 50 degrees, or in the
Yes.
vicinity of that. Will it still be airtight when it expands and withdraws?
Yes, we have a seal part in the product which keeps it airtight. And between this temperature, the properties of polycarbonate don't give any significant extension. Because it's up to, I don't know the minus limit, but the plus limit is 120 degrees.
Minus 40 degrees to 120 with the
To
flat
120,
pressure.
so we won't have that extreme conditions.
Any more questions?
What dimensions you are talking about actually? Just 1 millimeter or 10 centimeter or?
How big is the ring?
The
ring is 13 centimeters. Diameter is 13.
Yeah.
Or that.
Yeah, it's just
Yeah,
as
like
big as
people.
it allows you to make your visual